Good morning, it's Dave Kenworthy here again. It's the 21st of the 8th, 2021, and we're going to talk about relationship that's been discovered by a metrologist who publishes his work on the Graham Hancock website, and he's called Jim Alison. And this was brought to my attention by Melissa, so I'd just like to say thank you to Melissa for flagging this. And what it is his analysis of the Shusi against Berryman's Egyptian digit is a complete reconciliation using the relationship. The Egyptian digit is 10 units when the Shusi is 9. And I've had Berryman's book for a while, and I completely overlooked this. And it's so obvious once it's pointed out. But I just want to go through Jim's workings. And this is going to be really difficult because there's a lot of complex metrology in this. And Jim's working at a really high level here, understanding the geodesy involved here, the geodetic aspects of this work by Berryman. So what I've done is I've taken Berryman's Shusi, which is 0.66 inches, and it's here in the corner there. Berryman Shusi, 66/10. And I'm using fractodecimal notation here. So Jim is using these numbers across the bottom, but I've put in the whole number fractional mathematics. And the Shusi that Berryman is working with in his book Historical Metrology is 66/100. And what Jim's done is applied a factor to that, a well-known Egyptian mathematical factor of 175/176. And when we multiply that across, we get 11550/1600. And we know that there are 1760 cubits in the base of the Great Giza Pyramid. And then Jim's applied another factor. This is the factor that I've talked about, this 10/9 factor, to this Shusi that is produced. And it gives a digit of 115500/1584. And 1584 multiplied by a lot of zeros is the number of inches in the Great Circle. So we're using two units here, 17600, which applies to Giza, and 1584, which applies to the circumference of the Great Circle, which scales down to the circumference of the Earth. And we're also using here, to get the height of the Giza Pyramid, we're using the Egyptian foot, which is 16 of these Berryman Egyptian digits. So there's a huge amount to go through just in this one page. And on top of that, we're using this factor that Jim has produced here, of 175/176, and as a decimal it's 0.9943181818 recurring. And as a foot, multiplying that by 12, it's 11.93181881 inches. And we can see that the relationship between the Shusi and the foot of 12 inches, so 0.66 and 12 is 0.055. And it's still the same when we apply this factor, because everything scales down in Jim's analysis. So the foot is this, and the Shusi is this, and it's still the same, 0.055. And this is the new metrology. So the relationships between the units are fixed, but the units themselves are variables. So for example, the cubit multiplied by 1584 is the megalithic yard. This relationship is fixed regardless of the length of the cubit and the megalithic yard. So if somebody comes along and says the cubit is 20 inches, we multiply that by 1584 to get the megalithic yard. And the base 100 cubit is 20.833 inches. We multiply that by 1.584, we get 33. That's the megalithic yard at the base 100 Giza Pyramid. So, as I say, this is very complex, and we've got the base 100 cubit here. So what we're going to do is look at how we can get this figure from this work of Jim's here. So, I'll go through it again. The Shusi and Jim's book is 66 over 100, 0.66 imperial inches, where 1 imperial inch and 12 imperial inches make a foot. Now that's what's being used here, but Jim is saying that the ancients were using these shorter measures, where the foot isn't 12 inches, it's 11.9318182, and the inch is 0.99431818 of the imperial inch. And when those measures are used, we get a Shusi of 0.65626 inches. And where this comes into play is when we factor this out into the Earth's circumference. And I'm going to work through how we calculate the Earth's circumference, but what I want to do first is just take this digit, multiply it by 16 to get, this is Berryman's Egyptian foot there. So that's very important, it's in his book. And the reason it's important is because when we multiply it by 500, we get 5833.333. In the new metrology, that's the height of the Giza Great Pyramid, the Great Giza Pyramid. That's the height of it. And when we divide it by 280, we get the cubit length, which is 20.83. That's the base 100 cubit. And it's coming out of this digit. So what Jim has found is the digit that creates the Egyptian foot that when multiplied by 500 gives the height of the Great Giza Pyramid that complies with the measure that Howard Weiss worked out when he first saw the Virgin Giza base, when it was cleared. He did it with the French people. And this is the base that I'm insisting must be used to work out the height of the Giza Pyramid, and here it is. And the metrology is very complex. So I'm going to take this further now. But first of all, let's just congratulate Jim for working this out, because we can see how complex it is. And I know he's been working on these kind of calculations for a long time, and this one's borne fruit for him. It's a fantastic piece of work. So I've said we can see the fractodecimal notation telling us what was going on in the designers' minds. So when we use that figure there, it doesn't tell us they're using 175 over 176, and it's producing these figures here. But we can see that using the new metrology. And I've put this is brilliantly deduced by Jim, and there's no argument. There can't be any argument about this. He's following all the correct procedures and principles that are involved. And he's working out this digit, which is Berryman's, from the Shusi. And it's all done perfectly. So let's move down now and see where we go. We can further use the new metrology to identify the length of the Giza base and corresponding Earth circumference. And this is what I'm saying about what Jim's doing here. Jim's giving us this figure, 24857.95455, as the ancient designers' estimate of the circumference of the Earth, which is so close to the correct estimate for the polar circumference. And the way we're doing this is we've got the digit here, which is 115500 over 158400, 0.7291666 recurring imperial inches. And in the Giza base, in the new metrology, there are 50,000 digits. So what that gives us is 5775000000 divided by 158400. And Jim's Giza base, and I'm not sure that he's actually calculated this, is 36458.333 imperial inches. And to get the Earth's circumference, again in the new metrology, we need to apply a factor of 43200 to this unit here. So we multiply by 43200, and we get the Earth's circumference as this, divided by this, giving 1575000000 imperial inches. So we can convert that to feet by multiplying that by 12, which gives 1900800, and we get 131250000 imperial feet. Now what Jim has told us is that the Indus Valley foot in his system is 13.125 inches, and we can see why. Because the system that I'm suggesting is the base 100 system uses a foot of 13.2 imperial inches, and Jim has factored that down. And the 13.2 inch foot will give an Earth circumference of 25,000 miles, and we're going to look at that. So analysing the outcomes, what is this stuff telling us? The Giza height in these findings is 500 times 16 Berryman digits of 0.729166. So it's 16 times 0.729166 recurring, which gives the Egyptian foot, as we've already discussed. We multiply that by 500, we get the Giza base. Now, using the system that Jim's discovered, we use pi as 100 over 32, and at the Giza base we use 2 pi. So 2 pi is 6.25. That's 3.125 times 2. And it gives, using 5833, it gives 36458.33. And that's 8,000 units of 0.7291667. That is so important that we're using this unit to get that figure, because nothing changes for the next calculation except pi. And what we find is the Egyptian foot multiplied by 500 gives that height, 5833.333 recurring inches. And this height also works with 44 over 7. And that's 6.285714286 in decimal. And when we multiply those two together, we get this kernel-wise measure for the base of the Giza Great Pyramid, and it's still the same. It's 8,000 of these units, giving that. Now this is the base 100, and this is the base 100 divided by 176 times 175. And again, we're saying there are 1760 cubits in this length, and there are 175 in this length. There must be, because that's the ratio. So we can pull this one down and see what happens. There are 1750 cubits in the Jim Alison base. So that's his base divided by 1750, and it gives the base 100 cubit. This is the new metrology. It's based on this cubit. There are 1760 cubits in base 100, and that gives this gives the kernel-wise amount, which is what I've been saying for a long time in all these lectures. The base 100 cubit is 20.833. If we multiply that by 4.8, we get 100. Right. Now the inch that Jim is using is this. So what I'm saying now is that this is a double proof of the integrity of Jim's findings in the base 100 new metrology qubit of 20.833. So let's have a look at where this is taking us, because this is fantastically complicated. It's taken me a long time to work it out. But before Jim worked out where the Shusi sat within the ancient units, I knew from my book, From Stonehenge to Giza, that there are 10,000 units in a Hugh Franklin megalithic inch. There are 9,000 units in a Alexander Thom megalithic inch, and there are 8,000 units in a digit. And from that, using the work of Professor Greaves, I deduced that the finger has got 7776 units in it. And now, at the top of the tree, we've got the Shusi, which obviously has got the digit divided by 10 times 9, which is 7200 units in a Shusi. And we can put in the base 100 Giza base here and scale down this base against these numbers, and it scales down to the Thom megalithic inch gives a Giza base of 33,000 units, and we know that the megalithic yard, when this is the Giza base, is 33 inches. Now when we scale down to 8,000, we get a Giza base of 2933.333 units. That's an eclipse month. And when we scale down to the finger, we get 28512 units. And when we scale down to the Shusi, we get 26400 units. So in other words, we're scaling down this number to that one, that one, and that one, and that one against these ratios here. And we can see how these ratios are whole numbers. And what we can also do is work out how many units of these are in the Giza base. Because we know there are 40,000 megalithic inches. We know that the Thom megalithic inch is shorter than the Franklin one. And there are 444.44 recurring Franklin megalithic, Thom megalithic inches in the Giza base. There are 50,000 digits. We've been using that number for a long time now in the presentations. The finger is working out at 51440.33, which is a strange number, but there's a reason for that, because we've gone to base 12 here. And the Shusi is 5555.555 recurring units. So we can see that there's a lovely symmetry about all this. And when we use this as the base ratio 1, we find the finger is the Shusi times 1.08. We find the digit is the Shusi times 1.111, which is 10 over 9. Thom's megalithic inch is the Shusi times 1.25, and Franklin's megalithic inch is the Shusi times 1.3888 recurring. I think if we multiply that by 12, we get 16.66. So you can see that these ratios are built on very, very elegant proportions. So the next column, I've looked at centimetres, because I know that in the finger there are 1.8 centimetres, and this means that in the Shusi there are 1.666 centimetres. In the digit there are 1.85185 recurring. This is the interesting number. In the Thom megalithic inch there are 2.0833 centimetres, and I found that in my work on Thom's book, and that is the base 100 cubit, if you multiply it by 10. And then this is a bit of a strange number for Franklin's megalithic inch, but it's just that times 10 over 9. And 10 over 9 is a theme amongst these arrangements. And now we go to the metre, which is the most telling line, I think, in the whole presentation, because in a metre there are 60 Shusi. That's it in centimetres. If we multiply it by 60, we get 100. The finger is 55.555 in a metre. And look, we've got that number in the Shusi here. So we can see how there's cross-fertilisation here in these analyses. And the next one is this, 1.851851 centimetres in a metre, because there are 54 digits. So that times that gives 100. And then the next one we go down to 48 and we get 2.083. That is 100. And then the final one we get this beautiful number 43.2, which is an Earth circumference number, and it's if you divide it by 12, you get, let's have a look, 3.6. 360 is an Earth circumference number, obviously, because it's the number of degrees. So really, I've just got to analyse Jim's proposal now and look at what he's actually suggesting and whether or not it's stacking up against the new metrology. And what Jim is suggesting is that because his calculation is giving this Earth circumference, which is so close to the polar circumference, it must be correct. But my suggestion is that is only 99.4318181% of the whole system, which is base 100. And if we use base 100, we get 25,000 miles as the Great Circle. And we get 36666.666 recurring inches in the Giza base, which is Weiss's measure. There's nothing wrong with Jim's proposals, and they're standing up fantastically well, and he's brought the Shusi into the whole analysis. And for me, Jim is arguing that he's discovered the correct unit of measure, and my suggestion is that the correct unit of measure is 0.66 inches for the Shusi, which is the one that Berryman uses in his book. But this is a fabulously interesting situation to be in, where we're agreeing that our measures and our calculations are all working together, and I've been able to fit the Shusi into this analysis, because this analysis here is in my book, From Stonehenge to Giza, in the introduction, because it's so important. And this unit, 36458.333 inches, is the Giza base. It's showing us that is a solar year, and the only unit that can produce that is 100 inches. And the solar year at Giza is produced by a unit of 100 imperial inches, and that actually represents 5 hours in time. This is very complex stuff, but I thank Jim for his work here, and again I thank Melissa for bringing it to my attention. So thank you very much. That's it for now.